Okay, welcome everybody to today's webinar and meeting sponsored by the CTS Transportation Safety and Traffic Flow Research Council. My name is Tony Fisher. I'm a transportation planner at the Metropolitan Council, and I am the chair of the Research Council. So the CTS councils provide a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. They bring together university faculty and staff with practitioners from the public and private sectors to recommend direction and participate in improving the center's research, education, and engagement programs. Today's webinar will feature a presentation on the guidelines for three-lane road design and operation. I'll share a little bit more about that in a moment. But first, I'd like to turn it over to Joe Gustafson to introduce himself and to go over some of the housekeeping details.
Good morning, everyone. I'm Joe Gustafson. I'm the traffic engineer for Washington County. I'm also this year's co-chair of the Safety and Traffic Flow Council and doing double duty as the co-chair of the Safety Committee for the Minnesota County Engineers Association. We're looking forward to audience participation and questions this morning, and we encourage you to use the raise hand feature or type the word share in chat if you have a question or comment. Then we can unmute you to share verbally. Or if you prefer, you can use the Q&A at the bottom of your screen to type your question or comment for the speakers, and there will be Q&A following the presentation. For those that need professional development credits, this event meets the continuing education requirements for 1.5 professional development hours and 1.5 American Institute of Certified Planners certification maintenance credits. The PDH form will be uploaded to the chat for anyone who needs it. We do have some other spring events coming up that I want to mention. CTS will hold 3 other transportation research webinars this spring that you may be interested in. One of these webinars has been announced and is listed on the screen right now, and the other 2 are in the works and will be in April. Additionally, we'll be having an all councils meeting in person, COVID permitting, that will be held on May 9th at the University of Minnesota's McNamara Alumni Center. The topic will be Bending the Curve, addressing troubling trends in Minnesota's traffic fatalities. More information about this meeting will be announced in the coming weeks, and all of the events are free and anyone is welcome. And finally, if there are any students joining us today, could you please send a chat with your name? We do track the number of students who are engaging in our events. So thank you, and I'll turn it back over to Tony.
Thanks, Joe. So I just want to take a moment to appreciate the efforts of CTS staff. We have with us today Gina Boss and Katie Kirk, who do a lot of work behind the scenes to make these possible. And without further delay, let's jump into this. So today's webinar focuses on guidelines for 3-lane road design and operation. Road diets, which convert 4-lane undivided highways to 3-lane cross sections, are an innovative solution to address mobility and safety concerns within financial constraints. Past research has primarily focused on evaluating the safety of road diets, but there's been less research on the operational effects of such redesigns. This lack of guidance can lead agencies to avoid conversions on roadways with ADTs greater than 15,000 vehicles per day, even though anecdotal evidence suggests successful operation of 3-lane roads with ADTs upwards of 25,000. So I am pleased to welcome today's speakers. We have with us Gary Davis, professor in the Department of Civil Engineering, Civil, Environmental, and Geoengineering at the University of Minnesota, and Jordan Kosak, transportation planner and pedestrian and bicycle coordinator at Hennepin County Public Works. With that, I'll let Gary take it away.
All right, thanks, Tony. Let me make sure we get going here. All right, somebody give me a thumbs up if you can see my screen here. All right, looks like we're good. All right, so what I'm going to talk about today is a research project that we're in the process of completing, supported by MnDOT and the local road research board. All right, essentially looking at volume warrants or volume traffic volume related conditions, okay, that might justify or not justify, okay, a 3-lane design. So just as a quick summary, the road, the 4-lane road on the left has been converted to a 3-lane road there on the right, okay, with a 2-way left turn lane in the middle. That's the sort of conversion that we're talking about. These sorts of conversions are listed as proven crash reduction countermeasures in the Highway Safety Manual. You can see that we free up some space that could be used for parking or bike lanes. There's at least some acceptance to the idea that it might make it easier for pedestrians to cross the road, that roads under this condition sometimes are seen as more livable, okay, than the older 4-lane conversion. But the interesting question, all right, is under what conditions, okay, will this reduction in capacity, okay, the road on the left-hand side clearly has more capacity for through traffic than the road on the right-hand side. Under what conditions will this capacity reduction be more or less benign, okay, so that we can go ahead and take advantage of some of these other possible benefits from this conversion here. So for this project, essentially, we started out from scratch and we went through and identified 36 different design features having to do with the 4-to-3 conversions here. And essentially what we want to do is see what did the literature have to say about these. And we identified almost 50 different sources that discuss these issues. The student that was working on this, Jingru Gao, compiled a summary table, okay, that identified which sources addressed which features. We presented this information to our technical advisory panel and asked them to rate what of these features they considered most important. And 4 of these came back as basically more or less unanimous agreement among the members of the technical advisory panel that these were important. And then in a discussion with the TAP, all right, it was decided that we'll focus on main road traffic volumes as our first priority in order to start trying to identify conditions under which a 4-to-3 conversion might be more or less benign here. The literature on this topic is probably the most extensive of any of these design elements here. And so once again, a strong component of this literature is basically simulation studies at signalized intersections. All right, so on the left-hand side, we've got a signalized intersection with its turning movements illustrated. And then on the right-hand side, we've got the signalized intersection as it might appear after we've done a 4-to-3 conversion here. And then essentially what happens, what's been done in the literature is simulation software such as Synchro or something else, okay, is used to simulate the performance of this intersection, okay, in the before and after conditions for a variety of different traffic volume levels. And we identified 3, okay, what we consider as important studies, okay, that address this issue. The first one was done at Iowa State almost 20 years ago now. And the recommendation that came from that study was that, well, for the, essentially, one of the things you got to think about here is the guidelines are given in terms of average annual daily traffic, but you can't actually simulate an average annual daily traffic in a traffic simulator. You have to actually specify a set of existing conditions, okay, in order to simulate. And so the convention is to take your average annual daily traffic, cut it in half to get directional flows, and then assume that 10% of that daily directional flow happens during the peak hour, okay? And we'll use that convention in what we'll talk about further here. So anyway, the recommendations from the Iowa State study was that, well, if your AADT converts to a hourly directional flow of, I guess that would be, cut it in 10 to 1,500, 750 vehicles an hour, okay, per direction per lane. All right, then the 4-to-3 conversion is feasible. And in this range of 15K to 17.5K, then they recommend you exercise caution. And above 17.5K, then the feasibility of the conversion is less likely here. A later study done at the University of Kentucky, okay, looked at one single intersection. And what they found, okay, was that essentially what's different here is they looked at the traffic flow on the converted road down here on the x-axis, and then traffic flow on the crossroad over here on the y-axis, and looked for combinations of flow in these two directions, all right, that either justified or didn't justify a conversion here. And so they came up with this boundary line here, this blue line, and everything below that line are combinations of the two directional flows, okay, where a 4-to-3 conversion is likely to work. And then this red line here, basically that's this corresponds to this 23,000 ADT that there's been some suggestions in the literature, all right, that conversions up to that point might work. And so we got about 23K down here on the x-axis, about 23K up here on the y-axis. That's just a line that connects them. Above that, they recommend that the 4-to-3 conversion is probably not going to work. And then in between these two lines, okay, the recommendation was that, well, it might work, but you got to give it a bit more case-specific thought here. And then finally, a more recent study was done at Michigan State University. And what they did was they took a number of actual existing intersections and with actual existing turning movements and simulated their performance, okay, either with or without the 4-to-3 conversion. And they came up with a much more restrictive recommendation, all right, that basically, that, let me see if I can get a pointer working here. There we go. All right. Their recommendation was that the ADTs below about 10,000, the 4-to-3 conversion might work. All right, but above that, it becomes progressively more problematic here. And one of their recommendations was that basically because of the variation in intersection geometry, turning volumes, and signal timing from site to site, they saw a fair amount of variability, okay, in the performance of these different intersections. All right, a detailed operations analysis, okay, should always be done. All right, and then in addition in the literature, there are several examples of sites that seem to be successful 4-to-3 conversions with fairly high average annual daily traffic volumes. And we identified 3 of those in the literature. And essentially what we did was we took a look, okay, at what sort of roads were those. And so this first one here, Lake Washington Boulevard in Kirkland, Washington. All right, here's a Google Earth view, okay, of that particular road with the 4-to-3 conversion. And essentially what you see here is that this is essentially a stretch of road, okay, with very few signalized intersections. All right, very few two-way stop controlled intersections, and most of the abutting access points are simply driveways here. And so this is, you might take this as a typical 4-to-3 conversion with a high volume, okay, that seemed to be working. Another one, this Grand Avenue in East Lansing, Michigan, we took a look at that, and that actually has a configuration similar to Lake Washington Boulevard. Most of the, again, very few signalized intersections, and almost all of the connections to the road are simply driveways, okay, without a lot of cross streets, okay, occurring along here. And then the final example, Ocean Park Boulevard in Santa Monica. This one was less clear cut. This looks a lot more like your typical busy street. All right, but again, the claim is that that seemed to be working fairly well, the 4-to-3 conversion, okay, even at these fairly high ADTs. And it's more difficult to make a generalization about this one here. So anyway, what we decided to do was another simulation study where we'll simulate not just intersections, but sections of road, okay, that endure the 4-to-3 conversion here. And essentially, what we want to do is we want to try configurations, all right, of traffic volumes, okay, that might support a 4-to-3 conversion with ADTs above 15,000 here, and try to identify these boundaries, okay, that define acceptable versus unacceptable level of service. And in discussion with our TAP, we picked 3 examples, okay, to do the simulation. A very short section of 50th Street in Minneapolis, a somewhat longer section of Minnetonka Boulevard in St. Louis Park, and then a longer yet section of Baker Road, okay, out in Minnetonka here. So essentially what we did is a factorial experiment. Okay, we had 4 levels of major road traffic volume, 500, 750, 1,000, and 1,250 vehicles per hour per lane, and the rough equivalents of those with the average annual daily traffics are given in parentheses here. All right, for each of those, we then looked at 3 levels of flow on the minor road or crossroad signalized intersections, 20, 40, and 60% of the target road flow. And then at the unsignalized intersections, we again looked at 3 levels of flow. And these are 50, 75, and 100% of the MUTCD limit, okay, for converting the two-way stop controlled intersection to a signalized intersection. And so this gives us a total of 4 times 3 times 3, 36 possible combinations, okay, of these different input values here. And so for each of these 36 combinations, essentially what we would do, okay, is first of all, time the signals, calculate the cycle length split and offset using Webster's method. Then we'd run 5 simulation runs, okay, with different random number seeds, and then average the results for the 5 runs, okay, to come up with performance measures. And we're looking at our delay at the signalized intersections, delay at the two-way stop controlled intersections, and then speed and delay on the main road links, and summarize the results. All right, turning movements. Essentially, I guess the main thing I want to make a point about turning movements, all right, is that we selected turning movements on the crossroads, all right, so that we preserve that main road flow all the way through the simulation section. So for instance, here we've got 75 vehicles an hour turning left off the target road. All right, we've got 75 vehicles an hour turning left back onto the road, okay, at this crossroad here. All right, so that we preserved our main road traffic flow all the way through the simulated section here. So let's take a look at some of the sites. Okay, I'll kind of go through these fairly quickly here. And the first one, again, was this 50th Street in Minneapolis here. It's a fairly short section, only 0.2 of a mile long. There are 2 signalized intersections at the boundary of the simulation section, and then 2 unsignalized two-way stop controlled intersections in between the signalized intersections. All right, here's an example of the simulation model that Jingru Gao put together here using a software called Transmodeler SE. And so here's Chowan Avenue, that's one of the signalized intersections. Here is Zenith Avenue, that's another one of the signalized intersections. And let me see if I can read this right. Beard Avenue, this is a two-way stop controlled intersection. And Abbott here, that's another two-way stop controlled intersection. And I'll just, no, I don't seem to have my animation working here. So we'll just kind of skip over that and move on. All right, so here's the kind of results we get, all right, from a simulation run. For each combination of main road flow, signalized crossroad flow, and unsignalized crossroad flow, all right, this is for westbound 50th at Chowan. And here's the signalized delay and level of service, all right, for each of the 36 combinations here. And then here's the average corridor speed, all right, for each of the 36 combinations. All right, and the thing I want to point out here is that for this direction, okay, so 50th is our target road. Chowan is one of the signalized intersections. So we're talking about flow on the target road at a signalized intersection. And what we see is that the level of service is pretty good all the way through all these possible volume combinations. even going up here to 1250, all right, which roughly corresponds to an average annual daily traffic of 25,000. So under these conditions here that we simulated, okay, there doesn't seem to be much of a problem, all right, at least for the folks actually using 50th to go straight through, okay, from point A to point B. When we look at one of the crossroad approaches at the signalized intersection, okay, this is northbound Chowan at 50th on the other hand, essentially in order to try to show what's going on a little bit more clearly, okay, what we've got here is our different levels of main road traffic flow, our different levels of crossroad traffic flow, 20, 40, and 60% of the main road here. And then we've also done some intermediate simulations between 750 and 1,000 to try to refine the boundary, okay, where level of service breaks down. So for instance, when we've got 500 vehicles an hour per lane for the main road flow and 20% of that is on the crossroad flow, all right, we get level of service B for this crossroad traffic here. And as the main road flows goes up, but we're still restricted to 20% of that, okay, we get all the way up to 900 vehicles per hour per lane, or roughly an ADT of 18,000, okay, still at level of service D. And here we cross over into level of service F. And then as the flow on the crossroad increases, all right, this boundary between acceptable performance and unacceptable performance, okay, starts moving, all right, in this negative direction here. And only for this fairly low crossroad demand, all right, do we get this acceptable level of service somewhere around 10,000 ADT. And so kind of what you can see here is that what you take for your crossroad flow has a pretty big effect on what you're going to come up with an average annual daily traffic sort of recommendation. All right, if the crossroad flows are fairly low, okay, then we'll come up or could come up with a recommendation as high as 18,000 for the ADT here. If the crossroad flows are higher, all right, then we're stuck down here at around 10,000. And so this is, one possible explanation, all right, for the difference between the results that, for instance, the Iowa State study and the Michigan study found in terms of their traffic volume boundaries, okay, that justify this conversion from the 4 to 3 configurations here. And then let me look at an example minor road, okay, flow. At a two-way stop controlled intersection instead of a signalized intersection. And we kind of see a pattern roughly similar to what was happening at the major road or at the signalized intersections, but somewhat less extreme. When we're at 50% of the MUTCD limit, we can get up to an ADT of maybe 19,000. All right, but the boundary between level of service F and not level of service F, okay, shrinks to some extent, all right, as the minor road flow demand, okay, increases here. So what did we find here at 50th? On the target road traffic, we got acceptable level of service, both at signalized and two-way stop control levels at hourly volumes greater than 750 vehicles per hour per lane, or ADTs greater than 50,000. That's on the target road flow on 50th. On the crossroad approaches for signalized intersections, on the other hand, we got substantial deterioration in the level of service when the target road flows are greater than 750 here. And on the crossroad approaches for two-way stop control conditions, again, level of service F conditions appearing at target road flows, okay, increase from 750, okay, to 1,000. All right, depending on the level of crossroad flow. All right, so I'm using up a fair amount of time here, so let me kind of go through the next two sites fairly quickly. Our Minnetonka Boulevard site, okay, was a bit longer, 0.7 of a mile. It was bounded by two signalized intersections, one at the junction for Trunk Highway 100 and one at Inglewood Avenue. And then it had a signalized intersection inside it as well at Ottawa Avenue. And it also had three four-legged two-way stop controlled intersections in there and three T-intersection type two-way stop controlled intersections. All right, kind of a little picture of it. Here's Minnetonka Boulevard. Here's Inglewood over here. Here's our junction for Trunk Highway 100 here. Here's our midpoint signalized intersection here. There's our transmodeler SE representation for what this example ended up looking like. All right, and then here's an example output, okay, on the target road, okay, which is Minnetonka Boulevard. So here's westbound Minnetonka at Trunk Highway 100. And we see a pattern pretty much similar to what we saw with 50th Street, okay, on the target road at the signalized intersections. We're getting acceptable level of service even at fairly high volumes. Okay, again, starting to knock up on this boundary of that correspond roughly to AADTs of 25,000. When we look at Crossroads at the signalized intersection, again, we kind of see a pattern similar to what we saw for 50th. The Crossroads, the level of service deteriorates fairly quickly, okay, after 15,000, roughly 15,000 ADT, and deteriorates even more quickly when we have these higher levels, okay, of crossroad traffic volume. And a similar pattern here at the two-way stop controlled intersections as well here. At the higher ADT levels, okay, we're getting level of service F, all right, but at some of these lower volumes, okay, we again can have roughly acceptable performance, again, depending on, okay, the volume, okay, on the minor road here. And so essentially we found a pattern here on Minnetonka Boulevard similar to what we saw there at 50th Street. That if all we do is focus on the traffic volume on the target road, things look pretty good, even at fairly high ADTs. The main effect, okay, of the conversion is being felt at the crossroads, okay, either at the signalized and the unsignalized intersections. And then our last site, our Baker Road site, was a bit longer, 1.7 miles, and there were no internal signalized intersections, and it had four-legged two-way stop controlled intersections, and then 10 T-intersection two-way stop controlled intersections. And its boundaries, well, County State Road 62 and Valley View were the signalized intersections that defined its boundaries here. And so up here, here's County State Highway 62, here's Valley View down here. And so it's this section here, okay, that we're interested in. Here's our transmodeler SE representation, okay, of the road. And so something I want to point out here is where this example is different is our boundary intersections here, okay, on our first two simulations, the crossroads were definitely minor roads compared to the target road we were interested in. All right, they were all one-lane approaches, had fairly low capacity, and that is, at least in part, the explanation for the deterioration in the level of service we saw at these higher volumes. All right, here at the Baker Road site, the signalized intersections that define the boundary are definitely major roads. Okay, we have much higher capacity at these signalized intersections than we saw in the previous two examples here. And that's going to make a difference in terms of the results that we got. So again, here's our target road is Baker. Here's northbound Baker at one of the signalized intersections. And we see the pattern similar to what we saw in the other examples with a fairly decent level of service, even at fairly high corresponding average annual daily traffic levels. For the crossroads at the signalized intersection, here's the conditions on Highway 62 at Baker. The much higher capacity that this road has means that essentially we see a level of service pattern on the crossroads similar to where we're getting on the target road. Decent level of service all the way down, okay, to these fairly high traffic volumes here. And then looking at the target, one of the flow on a crossroad. Okay, this is Holly Road at Baker here, for instance. Here, the pattern is similar to what we saw on the two-way stop controlled intersections at the other two examples. Okay, once again, we get kind of decent level of service, okay, as long at fairly high volumes, even if the as long as the demand, okay, on the crossroad is not too high, and then tending to break down a little bit, okay, when we move up to these higher volume levels. And so at Baker Road, in part, the results were similar to what we saw at the other two, okay, on the internal intersections. The main difference here was that the signalized intersections at the boundaries had much higher capacity, so we didn't see the flow breakdown, all right, that we saw with the preceding two examples here. And so just to summarize what we think we found out here for this, okay, if you're thinking about a 4-to-3 conversion, all right, okay, the first thing that you got to worry about is, well, the signalized intersections are going to be a main constraint. If you don't have enough capacity at the signalized intersections to deal with the higher volumes, all right, then the 4-to-3 conversion, okay, is something that is going to require some thought here. Okay, and that is determined both by the capacity on the target road that's receiving the conversion and also the capacity available on the crossroads. If the signalized intersection capacity is okay, all right, then the next thing to worry about is what's going to happen at unsignalized intersections in between, I guess, the signalized intersections. And here we've got basically a different phenomenon operating. Okay, capacity of the signalized intersections is governed by the signal timing. All right, capacity at the unsignalized intersections is governed by gap selection. And so it's going to be the effect of the 4-to-3 conversion on the availability of gaps that's going to basically determine, okay, whether the 4-to-3 conversion is going to be benign, okay, or not benign. And then finally, okay, if you've got okay capacity both at the signalized and unsignalized intersections, then there's the possibility of speed reductions on the main road, okay, that needs to be given some thought. In a sense, we're taking all this main road flat traffic that's in 2 lanes and moving it into 1 lane. What we know from basic traffic flow theory, that's going to increase the density on that road and therefore have some sort of reduction in speed. And just for what it's worth, at least sometimes that reduction in speed is seen as a benefit of the 4-to-3 conversion, okay, rather than a deficit. And basically guidelines based solely on target road average annual daily traffic by themselves, okay, without consideration of other other site-specific considerations, all right, can be misleading here. And with that, I'll finally wrap it up. And eventually we'll be available for questions and discussion. Thank you.
All right, I'm next. I'll reintroduce myself. My name is Jordan Kosak. I'm a transportation planner with Hennepin County Public Works. Sorry, just making sure. Can everyone see the presentation all right?
Good.
Great. So I've been participating on this study, and they asked me to give a little local flavor, how we think about 4-lane undivided roads, 3-lane roadways at Hennepin County. In my work with Hennepin County, I do deal with this topic a lot. I work on a lot of restriping projects where we overlay a road and have an opportunity to reevaluate the striping. And I also have been participating on a number of larger reconstruction projects where we're also looking at implementing 3-lane roadways. A few things I'll talk about today. The background, kind of just in general, where we're at Hennepin County in terms of thinking about 3-lane roadways. Give a little information about an ongoing countywide study we're doing on this topic, and then look at one case study. So just to start with some background, this map shows where all of our existing 4-lane undivided roadways are with the ADT. The red is greater ADT, 22,000 to 38,000, all the way down to green, which is around the 15,000 range. So we have a big spread. Urban core, first ring suburbs tend to have a little higher volume roads, but it's pretty well distributed in terms of ADT levels throughout the county. So this next map shows where we've already converted 4-lane undivided roads to 3-lane roadways. The solid lines are completed conversions. The dashed lines are either in progress or programmed. So Hennepin County's had quite a bit of experience with this over the years. But we're still evolving and learning as we go, and implementing new best practices and new ideas. We do get a lot of our guidance, as Professor Davis kind of noted in his presentation. We get a lot of guidance from FHWA as well. The first bullet there, that you typically see 19 to 40% reduction in crashes. I think our data generally bears that out when we've evaluated our 4 to 3-lane conversions, and then that hourly volume guidance is the peak hour below 750 vehicles, between 750, 875, or above 875. We tend to adhere to that at this time pretty closely, and generally it kind of matches with what we're seeing when we do operational analysis or modeling on a corridor. We find that guidance to be a pretty good fit for us. So then I'll talk a little bit about this. We're calling it our 4 to 3-lane roadway conversion study. And why are we doing this study? A big piece is to better understand operational impacts and trade-offs of doing 4 to 3-lane conversions on our system. We have varied professional opinions about what acceptable trade-offs are, what the right vehicle volume thresholds are. And so we see this study as a way to establish a consistent county practice, consistent county approach when we're considering converting a roadway. To date, it's really been project by project basis, and we hope this can kind of help us have a better starting point when those opportunities arise. And then finally, roadway safety. As noted earlier, converting a 4-lane to a 3-lane roadway can have really big safety benefits and crash reduction. And roadway safety is a big priority for us at Hennepin County. So that's a big factor in some of the decision-making process. And these are so I mentioned that the study is still underway. We do have some of the tasks completed, so I'll share some preliminary results. But this is just generally all of the tasks that we're looking at in the study: a literature review and peer assessment, before and after assessment, capacity guidelines, high-level screening analysis, and then a detailed analysis. And so we do have the peer review preliminary results. So I'll just kind of talk about some of those. We asked our peer agencies a series of questions. And those agencies are Washington County, Richfield, Scott County, Minneapolis, Dakota, and Anoka County, St. Paul, Ramsey, Hennepin County, and MnDOT. So the first is just how many miles of 4-lane undivided roadways are in your jurisdiction. Really varies. On the left end of the x-axis, Washington County has not even 1 mile, all the way up to MnDOT on the right-hand side with over 100 miles. And then the y-axis here in this chart is just showing what percentage of the system is a 4-lane undivided roadway. So Ramsey County looks like it's
Mm.
like way high, but they just have like 9.5% of their network is a 4-lane undivided. Most other agencies, it's closer to like 2% or less of the network is a 4-lane undivided roadway. Next question we asked is, does your jurisdiction construct new or rebuild existing 4-lane undivided roadways? And most respondents said they do not prioritize and or avoid construction of new roadways. So I think this just shows that by and large, agencies are trying to move away from the 4-lane undivided cross section. Often it's a 3-lane, not always. Sometimes it could be a 5-lane or 4-lane divided section, but I think it shows that people recognize that the 4-lane undivided roadway section isn't something we want to continue building into the future. And then the last survey question we asked, are there recent or completed 4 to 3-lane roadway conversions in your jurisdiction? And for any recently completed, can you offer best practices or lessons learned? We received a lot of responses. These 3 I just felt were somewhat representative of the overall responses. So consistently found that conversions significantly reduce crashes and operate well. The project required a lot of communication and education, but led to a community accepted project. And 3 lanes likely have more capacity than many think and can outperform operations of a 4-lane undivided segment in the right circumstances. I just want to go back to that second bullet. In my experience, having done a number of 4 to 3-lane conversions and been part of the community engagement process, that bullet, that sentiment really rings true to me. I think, on the back end, we do modeling. There are other factors that come into play, but the community engagement, if you actually want to go out and implement it, is a really big factor. And it really varies community to community. In the city of Minneapolis, for example, we have residents who are asking us to implement 3-lane conversions. Then we go into some of our other suburban communities. People are less familiar with the benefits and the operation of a 3-lane, and more education is needed to help those residents understand why we're making the decisions that we're making. So I think when you go out to implement, that's really a big key, is letting the public know why and how it will benefit them. So then just going to talk about some of the other tasks that we're looking to do in the study that haven't been completed yet. We are going to look at capacity guidelines. So we're going to look at sources from literature review and peer assessment to do a before and after assessment. That will include AADT, peak hour, directional volume, other considerations. We're looking at Broadway Street Northeast, Portland Avenue, Maryland Avenue, and Larpenteur Avenue, the last 2 in Ramsey County. And the reason we're looking at those is they all are roadways with higher levels of AADT. So we're really trying to understand for us what's that ceiling, because we do think it's above the 15,000 that Professor Davis cited earlier. We think it's possible to go a bit higher, although to date at Hennepin County, we really haven't gone much higher than that. There's been a couple exceptions. And these guidelines will distinguish between various arterial roadway characteristics, including traffic control, curbside use, and access density. And the access density is another interesting point for us, because some roads have a lot of driveways, intersections, alleyways, and others do not. And in the literature review, we didn't find too much that was focused on that or spoke to that. So that'll be an interesting thing for us to see, like how big of a factor is access density in the operational impacts to a 4 to 3-lane conversion. Then we're going to do a high-level screening analysis, looking at 22 corridors on our system. It's basically all outstanding 4-lane undivided roadways on our system that aren't already planned or programmed. Again, looking at motor vehicle traffic capacity thresholds, such as curbside use, transit, lane utilization, speed, access density, and land use. And then finally, we'll look at a detailed analysis where we'll select 10 corridors and really drill down on those and look at them in a lot more detail, do traffic operations analysis using synchro and sim traffic, and bring in a safety analysis. I mentioned earlier that safety is a really big consideration for Hennepin County. So we want to be cognizant that for us, decision-making might not only rely on what the traffic operations look like. There might be trade-offs that come into play where we could be willing to accept some operational impacts if we know that we're going to get bigger safety benefits. So more to come on that study. I'm going to move into my case study. This is 66th Street Reconstruction Project in Richfield. There was a 4 to 3 lane conversion from Nicollet Avenue to Richfield Parkway completed in 2019. In 2016, the AADT was pushing that 15,000 threshold, and I have some prior year and before and after crash data to share. The project itself was bigger than the limits I gave, so what this map shows is done in 2 phases. So the orange was 1 phase, the blue was another phase. Nicollet to Richfield Parkway is the eastern end of the corridor going west from Nicollet. Majority of what we reconstructed is like a 5 lane divided roadway, so not quite applicable to the conversation today. And features of the reconstruction. So it was a full reconstruction, upgraded utilities and drainage, stormwater management. We implemented raised medians in a lot of areas with 2-way left turns to separate traffic, provide a safer pedestrian crossing. Like I mentioned, some sections were 3, some were 5 lanes. Bicycle facilities, so we implemented dedicated bicycle facilities separated from motor vehicle traffic, as well as enhanced pedestrian accommodations. All curb ramps were ADA accessible, traffic signals upgraded and accessible. Roundabouts at Lyndale and Nicollet Avenues, in addition to an existing one at Portland, streetscaping improvements and improvements to bus stop waiting areas. So these images are just kind of a typical cross section of the corridor. So this is the old condition, 4-lane undivided. You have uncompliant curb ramps, narrow sidewalks, not a lot of separation from moving traffic for people who are walking along the roadway. And then the after condition, we've made things ADA compliant. We added 1 travel lane in each direction with that center median and center turn lane. Here, this image has both. It's kind of a left turn pocket. And then wider sidewalks are set further back from the roadway. The black line on the sidewalk area is a dedicated bike way or cycle track. So kind of, in addition to doing a 3-lane, making the street more of a complete street that accommodates comfortably more modes of travel. This is just the image of one of the roundabouts. The roundabouts have RRFBs to help facilitate people walking and biking to get through them. You also notice, I believe most of them kind of expand a little to this 4-lane, 2 lanes in each direction to get through the roundabout and then go back down to the 1 lane in each direction. I'll get into a little of the crash data, the results that we're seeing from before and after implementation. Our before years are 2014, 15, and 16. Our after years are 2019, 2020, and 2021. So before, we had a crash rate of 5.07. You can see pretty big reduction there. Additionally, the crash severity rate, a reduction, and then just total number of crashes, we're seeing a reduction. And just for a little context, our average crash rate for a 4-lane undivided road in Hennepin County is 1.16. So, the before crash rate was well over that. And then just in general, total number of crashes, seeing a 29% crash reduction. So that is in line with that FHWA guidance of the sort of crash reductions you might see when you implement a 3-lane. Then just to get a little more detailed with crash types, the dark blue is the before years and the light blue are the after years. And here I've just broken out by crash type. So starting on the left-hand side, you have right angle crashes. We actually saw right angle crashes increase. And I don't have a really good explanation for that other than to say in 2019, where you do see a big increase in right angle crashes, there were still some punch list items happening on the corridor. So maybe, maybe some driver confusion people still getting used to the new roadway reconstruction. I don't really know. Next one over is left turns. And there you see, so far in the after condition, we've seen no left turn crashes, which is great. Rear end crashes are next, and that has stayed about the same between before and after condition. And then finally you have side swipe crashes. And again, we've seen a pretty big reduction in side swipe crashes with this new 3-lane configuration. So I think, especially looking at the left turn and side swipe crashes, which are very common crash types on a 4-lane roadway, I think it's good to see these results showing that when you do implement a 3-way or a 3-lane roadway, you see these sort of crash benefits, crash reductions occur. And then looking at vulnerable roadway users, pedestrian and bicyclist crashes, there weren't a ton in the before condition, which is the dark blue bars, but there's been no pedestrian and bicyclist crashes so far in the after condition. So again, that's good to see, especially given that people walking and biking tend to be more vulnerable roadway users. If they are in a crash, it tends to be more often severe or fatal. And then just total crashes, like I mentioned earlier, we're seeing those trending downwards, and particularly over time from 2019 to 2021, continuing to see a downward trend. Probably as people are getting more used to driving on the roadway and the new roadway configuration. I did have a streetlight analysis done for this corridor as well, just to look at how things are operating in a before and after condition. So AADT, and here looking at this graph, we've broken the corridor into 3 sections. So west, middle, and east end from left to right. And then the 2014, 2018 are kind of our before. So that's the blue and orange bars, and 2021 is after, that's the red bar. So we're seeing AADT stay pretty much consistent, somewhere around 14 to 15,000 vehicles a day across the corridor. This next chart is showing average speed distribution. So the leftmost 2 bars are the eastbound direction, rightmost 2 bars are the westbound direction, and then for each of those segments, the left bar is before, the right bar is after. Here we use 2024 and then for before, and then 2019 to 2021 for after. And what you're seeing here in the speed distribution is that we are seeing that speeds are getting a little faster in the 3-lane configuration. And that's represented by the bigger yellow bars, bigger green bars, which are 20 to 30 miles an hour or 30 to 35 miles an hour. The speed limit on the corridor is 35 miles an hour. So we're still not seeing a lot of speeding happening on the corridor. We're just seeing the speed distribution increase a little. And that kind of bears out in the average speed as well. So again, the leftmost 2 bars are eastbound, rightmost 2 bars are westbound. The blue is before and purple is after. So we're seeing a couple mile-per-hour increase in the average corridor speed from 22 or 23 to 25 miles an hour. And then average corridor travel time, same as before. Blue is before, purple is after condition. And we're seeing corridor travel times decrease, which kind of is in line with seeing a little faster speeds on the corridor. And then finally, we're seeing average congestion decrease slightly. And I think, one unique thing about this corridor is that we do have the roundabouts. So I think that definitely is probably helping play a factor in why we're seeing the speeds increase slightly, congestion, travel times reduce slightly. But there is at least one signalized intersection on the corridor as well. So it's not solely roundabouts that people are traveling through. And so with that, that is my portion of the presentation. I think we're moving on to Q&A. Thanks, Paul.
Yeah, thank you, Gary. Thank you, Jordan. A lot of information there, a lot of questions and thoughts in the chat and the Q&A, and I'm going to pass it off to Joe to manage that.
Great, thank you, Tony. So first, just a reminder for anyone that wishes to ask a question verbally, please use the raise hand feature to ask your questions. Otherwise, type your questions and comments in the Q&A feature, which is not the same as the chat. I see we've got 2 questions in the Q&A, or sorry, 3 questions in the Q&A so far. So first one, Jordan, you touched on the fact that there are some roundabouts in your 66th Street corridor. Question for both presenters would be any general thoughts on the merits of using roundabouts within this type of corridor? And I guess I'll start with Professor Davis to give Jordan a break.
All right. I have nothing quantitative, okay, to lay on that. The main finding, I guess, or finding from our research, okay, is again, it's intersection capacity, all right, that governs the volume levels, okay, where this conversion is gonna perform acceptably. All right, so as long as the roundabouts provide adequate capacity for the through movements, then it seems to me that it shouldn't make that much difference.
Yeah, I'll just add, I think often when we evaluate good candidates for a roundabout, we want to make sure that all legs are somewhat balanced so that, you know, in the 66 example, that's east-west, you want to make sure that people coming north-south have an opportunity to get in. So I think that's kind of one additional factor we might look at. And then I think another is just what's available right away, you know, the surrounding land use, that sort of context can help us make a decision on what's right to implement.
All right. Next question from the Q&A was, did you complete a comparison modeling for the 4-lane configuration? And the question was, don't we need to know the performance of the current configuration to compare?
That's a really good question. I guess maybe the first thing I'll say is that one of the things that we found out in doing this, all right, is that the combination of possibilities, okay, that can arise is so large that unless you restrict the focus of what you're doing, okay, it's going to be hard to even get started. All right, so the way we restricted our focus, okay, was that we wanted to define combinations of traffic volume levels that in a sense define this boundary, okay, between acceptable and unacceptable level of service when you had a 3-lane conversion here. And so that's why we chose to focus on just simulating what was going on the 3-lane roads, okay, so that we could prepare those tables like I showed you that kind of illustrate that boundary here. Certainly, we could have, simulated the performance of the 4-lane roads as well, but I'm, not so sure how that would have allowed us to say anything more about where these boundaries were, okay, than what we had already here. So I guess the ultimate comment is, yeah, I agree, okay, that a more complete or a more exhaustive comparison, okay, would have simulated the 4-lane configuration situation in all those configurations that we covered. All right, we opted to not do that, okay, because we didn't really need it to address the question we were looking at. And it was a very labor-intensive effort just doing the work that we managed to do here.
All right, Jordan, anything you want to add to that before I move on to the next question? Okay. All right, got to bring my window back here. There we go. So there was also a question in about kind of weighing the safety aspects versus what you described as acceptable versus unacceptable level of service. And I know that as an agency, we clearly say that no fatality is acceptable, but we also recognize that congestion on one roadway might divert traffic to other roadways that might, for example, have more vulnerable users. So any thoughts from either the modeling or the agency perspective on weighing these safety aspects versus level of service for users of the roadway?
For our study, okay, we received fairly clear guidance, okay, from our advisory panel that in this project here, we did not want to focus, okay, on safety related aspects, okay, so we didn't take those on. I'll just say that that's always a trade-off, okay, that one has to consider. As far as I know, there are no like explicit algorithmic methods, okay, that relieve you from having to use some professional judgment, okay, in making those trade-offs.
Jordan, anything to add from an agency perspective on those trade-offs?
Yeah, I guess, yeah, I will add, I think I mentioned this in my presentation a little. I wouldn't say that we have any sort of threshold or anything written in stone, but we do try to consider the safety benefits versus the operational benefits, and try to find, you know, something that can be workable for both.
All right, thank you, Jordan. Katie has alerted me that David Krulwich has his hand up and for a question, and she's going to unmute him. David?
Hi, can you hear me?
Yep.
Is there a way you can open up one of the photos you showed us, Jordan, with the complete streets and the bike lanes on the next to the sidewalk? I had a question about.
Sure, yeah, I'll present again. Does that
No, it was down. It was the it was the before and after.
that one?
Yeah. So, okay, this is a great treatment. It really looks great. I had a couple of questions. So, like where the light poles were and all that, was there utility relocation and drainage issues that those had to be moved, or am I mistaken?
Well, you know, redoing the utilities and correcting some drainage issues were part of the project. I'm sorry, I don't have enough detail to get too specific with you, other than, you know, those were parts of the reconstruction project to
Right.
improve those.
Yeah, because I've seen, you know, it's tricky to evaluate, you know, how much things cost. Sometimes it's easy to do this while maintaining the roadbed where it is and put the bike lanes, you know, in the road area, as opposed to like on the street like this, if you know what I'm saying.
Yeah, but and I guess you're saying it's
Like
somewhat.
how do you evaluate whether to do a treatment like this or to do something maybe less expensive
I
where the bike
see.
lanes
Yeah.
are in the road?
Well, at least at Hennepin County, I think, you know, undergrounding the utilities like we did here, that requires partnership from the city. That's usually sort of an above and beyond scope item, you know, in our funding for these projects. So we typically don't do it unless the city is going to be the cost sharing partner and something like that. So that would be one consideration. And then I think, you know, you're also right that, you know, those utilities do take up space, and that can play a role in how the bikeway and sidewalk are designed. You know, I guess I'll just, you know, that's just kind of something we have to deal with, and you know, it's just kind of a reality of the design process that those utilities and signposts, light posts do have to go somewhere, and it's not always thought about first off the bat, but it definitely becomes a reality as you progress further and further into a project design.
Right. All right. Well, thank you.
All right. I see we've got two more questions in the Q&A. One is, must be a question for Jordan. How much of the crash reduction on, I assume this refers to 66th, how much of the crash reduction is because of the 4-to-3 conversion, and how much because of the roundabouts? Did you attempt to separate those out?
Yeah, I didn't in this analysis. I just looked at, high level overall corridor end to end. What were we seeing for crashes? That's an interesting question. And it would be, I think, an interesting next step to see, because my understanding is sometimes roundabouts can actually have more crashes, but they might be less severe crashes. So yeah, I think that would be an interesting next step, but I don't have that off the top of my head.
Okay, thanks, Jordan. I actually have a question of my own I'd like to pose to both of you. Do you have, for an agency that might be considering a 4 to 3 lane conversion in one of these kind of boundary conditions, do you have recommendations for modeling or just the qualitative impacts of curbside uses such as bus stops or trash pickup? Any lessons learned?
Yeah, I guess I can go first. Bus stops are they're interesting, I think, from when you're doing the traffic modeling and looking at the operations. Metro Transit really prefers buses to stop in lane, but when you have a 4 lane road, it's kind of no big deal because people just can drive around the bus and it doesn't really become a factor. When you suddenly go down to a 3 lane road, at least in the modeling, it really starts impacting it because now you have something that's stopping traffic in the model. So I think it's kind of context dependent. Sometimes there might be opportunity to create a bus pullout. That's not what Metro Transit prefers. Like I said, sometimes we just accept that, yeah, it's gonna stop traffic behind the bus, and that's just something we have to factor in. Sometimes I think we try to play with like what's going to happen in the real world. So, if you have a 3 lane, there's kind of still is this middle space where people can go around a bus, and maybe it's not 100% legal, but if we think people are going to do it, we might try to just model what do we think people are going to do in the real world. And just kind of like play around and maybe see several of those scenarios just to get a sense of what we can expect to happen.
All right,
Yes,
Professor Davis, go
I have a
ahead.
lot to add to that. That's the thing about models, is that they represent or simulate an explicit set of conditions and don't deviate from that. And some conditions are not possible to represent. What just jumps into my mind, if I had to come up with an answer to that sort of problem, all right, I might say run my model, okay, with the buses blocking the main road, and then go out in the field and observe, what fraction of drivers use the 3 lane to get around the bus, okay, in a few configurations, and then just use that estimate, okay, to make a back of the envelope adjustment, okay, to what my modeling results are.
Thank you, Professor Davis. Next question was for Jordan. Tony Hall says, I'm surprised by some of the increases in speeds, especially those slightly above the speed limit in the second examples. Has Hennepin County considered deploying additional traffic calming in locations where the upper bound increases?
Yeah, I think we have. I can't speak specifically to 66th, but there have been other locations where we have concerns about speeds, and so we do try to implement various treatments to manage that, whether sometimes it's like a mobile speed wagon, sometimes it's like a permanent, this is your speed sign. It can be other elements as well. In the 66th Street instance, we did, in the after condition, we did see the high-end speeds increase, and that's the 35 to 40 mile an hour speeds. We did see those go up. In the westbound direction, though, we're still only talking about like 5.5% of all vehicles are over that speed limit, and in the eastbound direction, it's like 1.5%. So overall, it still is a pretty small number of vehicles. So I personally haven't heard too many concerns on 66th about speeds. That doesn't mean that there might not be problems at times, but I think overall, what the speed distribution we saw, in my opinion, is frankly pretty good. I kind of expected it to be worse given some of the anecdotal evidence out there during the pandemic, speeds increasing dramatically. So that's kind of what I think about that, I guess.
All right, thank you, Jordan. I see that there's been an assortment of comments put into the chat, some of which are questions. I don't know that I'm going to get to all those, but I did have one last one in the Q&A, which was more of a, Katie, I'm hoping you can unmute Howard Preston. He wanted to share a comment about the first 3-lane in the metro area.
Sure, let me go ahead and do that. Just 1 second. All right, there we go. Howard, you should be able to unmute. Or,
Don, can you hear me?
oh, we're having a hard time hearing you. Your audio. Could you speak up a little more?
Yes, I will, and I'll turn my audio up a little bit here. Joe, thank you. I didn't know if anybody would be interested in this, but I happen to have had a minor role in the development of the first 3-lane roadway back in about 1975. Ramsey County was in the process of attempting to widen Lexington Avenue in Roseville. At the time, the MnDOT guidance said any state aid guidance, any volume over, forecast volume over 10,000, the guidance said a 4-lane road. Roseville at the time was entirely opposed to the notion of a 4-lane road. I happened to be having a conversation with Paul Kirkwall, their traffic engineer, and he mentioned this problem, and I had just read the first research report I had ever seen on 3-lane roads. It was developed somewhere in Michigan, and mentioned to Paul that the recommended width of the 3-lane road that was in this research report was the exact same width as the 4-lane undivided width in MnDOT state aid guides. And if they wanted to, they could propose this as a 3-lane road to get it through the Roseville municipal consent, and then just not turn in a pavement marking sheet with their state aid plans. And if they like to, they could, the next time they needed to paint the road, paint it as 4-lane undivided, because you didn't need municipal consent for that. That's what happened. The road was built in Roseville as 3 lanes. And lo and behold, it is still 3 lanes because it has worked and improved both operations and safety for the last almost 40 years. So that a bit of a conspiracy to get the first one built, but that's how it was in 1975.
All right, thank you, Howard. I've got time for one more question here before we transition to our round robin. This was one I saw in the chat from Tyung Kim. Question for Professor Davis: what is the left turn operation of the modeling study in the first presentation? Is it permissive only, or was it something else?
At the signalized intersections on the target road, we assumed that there was a left turn lane with protected phasing, and then we timed it that way. On the crossroads, on the first 2 examples, these are all single lane crossroads, okay? So it was basically permitted phasing, okay, on those approaches.
All right, thank you, Professor Davis and Jordan, for your presentations. At this point, it looks like I'm supposed to turn it back to Tony for transition to round robin. Tony, take it away.
Thank you, Joe, and thank you to our presenters today, and thank you to our attendees who asked questions and shared their thoughts and history. We are going to shift gears for the last 15 minutes to more of the meeting portion of today. And I've got a few questions to pose to the audience. And let's see if I can put those in the chat. Oh, I'm sorry, Katie's got those in there already. Thank you, Katie. And yeah, feel free to respond. If you'd like to respond verbally, raise your hand. And if you'd like to respond in the chat, that's also welcome. But the questions are, what current transportation safety and traffic flow issues are you or your organization facing? Do you have any organizational, informational, or event updates to share? And what ideas do you have for potential future council meeting topics or speakers? And maybe I'll just start off with, one issue that we were facing at the Met Council and MnDOT's facing is really that the trade-offs with traffic flow operations and climate change and how improving the traffic flow can induce demand and affect land use. And so that's one big issue we're facing.
One here that appears to have possibilities.
Let's see, someone is unmuted.
I just corrected that. Yep, we're good.
Okay, so it looks like there's a couple of responses. I'll read those off for everyone. But otherwise, please raise your hand while I do that. Sonia states, okay, so that's more about the Q&A, it looks like. But yeah, we'd love to hear what's going on at local agencies, MnDOT, anybody else in the audience?
Tony, maybe I can help break the ice. As far as transportation safety and traffic flow issues we're facing, we're on, let's see, we're running into some issues lately with issues of consolidating access versus local ordinances on cul-de-sac length, and some of the challenges that come in when there have been planned interconnections for future developments versus the public negative reaction that results when people that live on those stub connections realize that that's now going to become a through road to another development. Also balancing that against a lot of localities have some cul-de-sac length requirements, which is precluding in some cases, or I should say it's essentially forcing a connection out to the county road, creating another intersection, another conflict point that wouldn't otherwise be there in lieu of connecting solely to an existing adjacent development. So it's creating some interesting questions as we work with some of our locals as these issues come up. Also, as traffic levels start to return to normal, or at least to a new normal, getting underway with some of our signal timing updates again. It was very difficult during the pandemic to know how long those patterns would last. So it made us leery of embarking on any signal timing projects for fear that those patterns would become obsolete. We're also updating our turn lane requirements, our warrants for that when developments come in. Looking at the side street and major road volume, trying to figure out what we ought to require. And we found that there's a very wide spread around the metro in terms of what agencies require. And I've yet to stumble across any consistent national guidance either. So if anyone has thoughts they'd like to share with me on that, please shoot me an email afterwards. And for safety issues, as always, we're doing what we can to improve safety, but we're on a wonderful streak right now. It's been, if we can make it till St. Patrick's Day here, it will be 18 months since we've had a fatal crash on our county road system here in Washington County. So always a pleasure to be able to share a little bit of good news.
Great, thanks, Joe. Yeah, I mean, I'd really like to hear, ideas that people have for future webinars. What are the questions people are asking? We'd really like to hear some perspectives on making progress. Let's see. I know there's one retired safety expert on the call that would have good thoughts for future topics. And some MnDOT people. Our favorite, maybe I shouldn't say that, but our a representative, state representative on the call that might have thoughts. Okay, we've got one hand raised. Let's see. Representative Elkins.
Yeah,
So
okay.
I really like Joe's idea of looking at cul-de-sacs, just because sometimes cities are able to develop a well-developed collector street system and include them in their comp plan, but it's a constant fight with the developers, and I think the implications on both traffic flow, traffic safety, and land use efficiency of cul-de-sacs and newly developing areas would be a great topic to look into.
Great. It's a second for future topic. And Corey Festfog has got his hand raised.
Also, Dave, maybe we can go to Dave. Let's see, Dave Elvin. I think he had his hand raised first.
Oh, sorry. Yeah, David Elvin, please go ahead.
Elvin, sorry.
That's fine. Thanks. Yeah, just a quick update on a study where I think a 4-to-3 conversion is going to be one of the things that's considered. Many of you on this call, I think, are involved either on the technical advisory committee, or maybe some of your elected officials are involved in the PAC for the Pell study of highways, University Avenue and Central Avenue from Northeast Minneapolis all the way up to County Road 10 in southern Anoka County. We're now developing a range of alternatives that we're going to be taking to the technical advisory committee at our next meeting that's coming up very shortly. Those of you who are on that will know about that in late March. And then there's going to be a series of community workshops the first 2 weeks in June, and really trying to tease out a very wide range of possibilities for these corridors. We're showing zero or negative traffic growth on these two roads for the next 20 years out, and with gas prices and other things coming along. I think there's interesting things that we can consider. So I'm really looking forward to input from people on this call in those engagement opportunities coming up in the next few months. Thanks.
Great, thank you, David. I'm just going to read off a couple of chats before we circle back to Corey then. Amy Marone from Bloomington says, I'd like to know if anyone has experience with using temporary traffic calming to address traffic diversion during regional roadway construction projects. So that sounds like a really interesting topic for the future. And Ken Johnson has in the chat, I encourage attendees to look at upcoming TZD workshops and attend if interested. And he's got the link there in the chat. And let's see here. Okay, why don't we give Corey a chance to jump in here?
Sure. And then we also have Steve Elkins and so whoever you want to go to first, I don't know.
Katie, this is Steve. My question has already been answered. I think.
Thank you. Okay.
I forgot to put my hand
Sorry
down.
about that. All right, so Corey,
feel free.
Corey.
If everyone can hear me. I was just going to reiterate what Joe had talked about with the cul-de-sac stuff, because we've run into a couple cases where due to local ordinances regarding emergency vehicles and lengths of roads that you can cul-de-sac, we too have, it would have been nice to get a couple housing units that did not want that. I mean, they themselves really did not want access to a trunk highway, but due to the length of that cul-de-sac, it ended up, we were not able to close an access and get it to a less busy side street. And on a different topic, I guess I would just mention that speed limits and the traffic speeds having to do with since the whole COVID thing started, that's a huge issue just in general. I mean, not even for just MnDOT, but for a lot of, I think, agencies.
Yeah, thanks, Corey. Thanks for bringing up the speed question. I think, let's see, was it Katie or Gina put in the chat earlier an upcoming event. See, May 9th, the CTS All Councils meeting the topic is titled Bending the Curve, Addressing Troubling Trends in Minnesota's Traffic Fatalities. And I think speed limits will definitely be a part of that conversation, or not speed limits, but speeds more generally will be part of that conversation. So Ben Manabog has a comment. I'd like to see new case examples or research on temporary on-street pedestrian or ped bike facilities. Not aware of any new examples in Minnesota. Yeah, that's a good point. Trying to keep those networks going. And then David Elvine shared in the chat the link to that Highway 47, Highway 65 study that he'd spoken about. Any other thoughts that people want to share?
Tony, maybe I'll just mention quick, earlier in the chat, we didn't mention it verbally, but there have been some links provided to a MnDOT page on road diets, and also an earlier LRRB study from, I believe, 2006 that looked at some of the safety and operational impacts of 4-lane to 3-lane conversion. So just a heads up, if anybody didn't see that, those links are in the chat, but you have to scroll up a bit.
Yeah, thanks for highlighting that, Joe. It's hard. We had a good discussion, so it's hard to keep track of everything. There is a comment here in the Q&A. Let's see, Eric Schiller states, I'd be interested in safety trade-offs when transitioning from 2 to 3-lane and where access management may be an important consideration. Yeah, there's clearly a lot more to the 3-lane question than the operations. But I think for good or bad, we have to satisfy a lot of people that operations is going to be at least good enough, whatever good enough means. So if there aren't any other thoughts or anybody with their raised hands, I think we are going to close it out and give you back 2 minutes of your day. Thank you for coming today. Thank you presenters.